Well, good morning, everybody. Thanks for joining us this morning. This is Jim Lacey at the State Cartographer's office in Madison. I think we've got a great session planned for you on geospatial cloud computing. I'm going to be acting as the moderator today, but our star attraction really is Mr. Michael Turner with Applied Geographics, aka AppGeo, out of Boston, Massachusetts. Michael, oddly enough, is actually joining us from the Google HQ in Mountain View, California. So good morning, Michael.
Good morning. Thanks for having me.
Appreciate you taking some time out. So I'm going to toss things to Michael fairly quickly here just so we can get going on the webinar. I do want to mention a couple things before we get going, however. I expect to have probably close to about 75 people on the line once we get moving here. So we do need to observe a couple little different protocols. First of all, if you're dialed in via telephone, please make sure you've enabled the audio controls, and you'll find the audio controls in your GoToWebinar control panel, which is typically on the right side of your screen. You'll see a 2-digit number, then type that number into your phone and hit the pound sign. That allows me to mute all the phone lines to make sure we don't have any background noise. In that regard, since we do have quite a few people on the line, I am going to keep all the phone lines and audio lines muted. So if you do have a question, if you want to speak, there's a little hand icon also in the GoToWebinar control panel. Just click on that hand when you want to speak, and I'll unmute your line, and you can ask your question. And I believe Michael's going to pause from time to time during the course of the show here to let folks ask questions. Alternatively, if you don't want to do it that way, you can certainly type in questions also in that same control panel. And I'll be keeping track of those questions, and when Michael pauses throughout the show here, we will I'll read off those questions, and we'll do our best to address as many as we can. Hopefully we get a lot of great questions from you guys. So with that, Michael, I'm going to throw things right over to you, and you can take it from here.
Thanks, Jim. And I appreciate everyone's interest in this topic. I've been doing a variation of this talk for the past couple of months. I actually participate in the National States Geographic Information Council, which is how I originally have met Jim, and first did a kind of 10-minute quick version of this talk at that organization. And since then, I've done a variety of presentations because there's great interest in this topic. And, you know, the goals of the talk is really to explain the potential that that the cloud offers to GIS, to use real-world examples of how it works. It's a buzzword that's out there. We hear a lot about it. We've been fortunate enough to have been doing it for the last 2.5 years, and really are in a position to share some of what we've learned and show how we apply it. The goals and the objectives are very simple. The cloud is a buzzword we've all heard tons and tons about. Our business has taken advantage of the cloud for the past 2 years or so and has a bunch of real-world examples of how you apply it, what it costs, and things of that nature. And we've seen over the past 6 months or so great interest in people understanding what we've been doing with it. And I put this presentation together to try and answer some of those questions. And as Jim said earlier, one of the important parts of this talk is to have an opportunity to answer your questions. So I have probably 20-25 minutes of content, and as Jim said, I'll pause regularly so he can forward on the appropriate questions. Interestingly, the last time I gave this presentation was actually at one of our company meetings to our own staff, because again, we do things like host websites, and some of the staff just doesn't know how we're using it, or the fact that our servers for our websites are in Amazon and things of that nature. And hopefully I'll put the pieces of the puzzle together for you. This slide comes from a collaborator of mine, Spencer Jenkins, who's the former director of the Utah State GIS Office, the AGRC. And Utah is a state where we provided some advice in some of their cloud investigations, and I'll actually end the talk with some findings from Utah. But Spencer gave a talk to the National States Geographic Information Council 2 years ago in Boise at the 2011 conference, and he made the very simple observation that GIS is a real perfect use case for the cloud because there's a low security risk. It's public data, so if people access it, that's kind of the point. There are enormous data sets, so if there are cost advantages having your enormous data set somewhere else, it's a good way to test it. And there's a culture of sharing in the GIS community in general. There's some exceptions to that, but in general, the GIS community is all in favor of sharing and using resources like the cloud to facilitate that. So what does Applied Geographics do in the cloud? We have a data center. We've had a data center for a long time. And one of the things that we do is we host websites for our customers. Currently, we host about 60 websites of all different kinds, Esri stuff, open source stuff. We do things for state governments. The Oklahoma site below is their state broadband map. We do esoteric sites. The map in the lower right corner is Tasmania, and all the dots represent wineries in Tasmania. It's part of what we do because it's hard for people to buy the server software, manage the server software, have a website that's on 24/7 and be available to fix it when it goes down and things of that nature. So, that's a big part of what we do with our data center. And one of the things that's put more pressure on the data center is a new approach that we've taken to some of the websites that we host. One of the downsides of having all different kinds of things is you have to manage all different kinds of things. And so for parcel viewing, which is one of the core kinds of websites that we host, we've, over the last 2 years, consolidated lots of different custom sites into one standard offering. And so really it's one piece of code that is used right now, as of yesterday, to host 47 separate sites spread in 7 different states. And then we're able to configure that code to provide a unique, access to unique data and some variability in the functionality that is presented. And so what it looks like now is, this is a map of where all of those sites are spread mostly across the Northeast. And sites are coming on, every week. In fact, the 47th site was launched yesterday. And this is what our architecture looks like, and this is kind of my segue into the cloud part of the presentation. We do lots of stuff on our own network, like processing Esri data, making tiles, and then we push that data up into Amazon's cloud, and we have 2 servers that manage the website, a PostGIS data server and a Microsoft IIS web server, and then our tiles are managed in Amazon's S3. And a lot of what I'll be doing in the next 15 minutes or so is describing what EC2 means and S3 means and where Amazon sits relative to other kinds of cloud offerings. But when people are accessing the website, they're going to Amazon. And it's actually been pretty interesting for me. I've demoed the website while I'm here at Google. Google has the fastest network I've ever been on. And so we basically have 2 of the web behemoths, Google, sitting in Google network, accessing a website from Amazon, and the speed is just astounding. I've never seen our websites move so fast. Makes me feel a little better because our code isn't slowing things down, at least. So just introducing some of the basics and the definitions that I'll be using for cloud computing. Cloud computing, Wikipedia has a good discussion on it. It's essentially computing resources that are delivered as a service over a network, typically the internet. So you're getting your computing resources from someone else other than yourself. That's it in a nutshell. But there's lots of different flavors of cloud computing. And again, some of the buzzwords you may have heard around there are infrastructure as a service, platform as a service, and software as a service. And what I'd like to do for the next couple of slides is walk you through what these terms mean, and then zero in on what Applied Geographics is doing, which is infrastructure as a service. We are using Amazon infrastructure as a service offering. So what is infrastructure as a service? And it's important to understand Amazon is just one of many players in this space. Microsoft Azure is a flavor of infrastructure as a service. There's a company called Rackspace that has this kind of offering, and you should definitely check out all that's available. We happen to use Amazon, so that's what I'm familiar with. That's what I'm going to be sharing. But there's lots of good opportunities out there. So in infrastructure as a service, the cloud provides computers that are available for your use as a service. So it's essentially the ability to create a virtual machine on someone else's server farm. And once you create a virtual machine, you control it. You can reboot it. You can install software on it. You can process data on it. You can post websites on it. But it's essentially a platform for you to make your own machines and manage your own machines, which is a little bit different than platform as a service, where you are provided an entire solution stack up in the cloud. So it's not just a machine that you have to control and put the security on and put the software on, but you are provided access to a platform that has capabilities. And I think I think it's no accident that that Esri in there just Esri's not out there saying this is a platform as a service offering, but I don't think it's a coincidence that on their website they're saying a mapping platform for your organization. There's an ability to move your data there. There's an ability to organize your data there. There's a capability of publishing your data. So there's all these solution stack components available through this website. Another example is this company CloudBees, that's essentially a development platform for Java applications. So instead of installing Java on your own systems and developing there and then deploying Java applications, you can do all of that on their platform. So, as the little blurb says, the CloudBees platform architecture provides a powerful foundation for cloud development and deployment. So you don't have to have your own servers doing it. You can use their platform for doing it. And then finally, there's software as a service, referred to as on-demand software, where software is delivered to you through the web. You don't have to install it. Salesforce.com is one of the sort of poster childs for software as a service. And this is their logo. It says no software. You're accessing just a service that has everything you need for their CRM offerings, customer relationship management. One of my favorite software services that I use quite a bit is something like Shutterfly, where I can take my digital photos and I can upload them into their cloud, and I can make books, and I can make Christmas cards, and I can make albums that my friends and relatives can look at on the web. And then, there are parts of ArcGIS online that I think also behave as software as a service. This is one of their out-of-the-box browsers. So without doing anything, you're accessing an interactive map that's hosted in Esri's cloud. So, Jim, I think this is probably a good place to pause. If anyone has questions about sort of the definition of the definitions I'm using of the cloud, or the distinctions between infrastructure, platform, and software.
Okay, sure. I think we do have one question. Jason, did you have a question? I've got your line unmuted if you do have a question. Jason's thinking, no, I don't have a question. I just clicked on the hand icon by mistake. All right, that's good. I don't see any other questions, Michael, so why don't you continue on?
Okay, great. So, you know, the cloud's out there. There's lots of resources to understand these offerings, and some of us may have encountered these offerings without really thinking about it as a cloud offering. So what led Applied Geographics to the cloud? We've run our own data center for a long time to run our own internal systems, and also, as I described earlier, for our hosting infrastructure when we host GIS websites to third parties. And it's not easy. It's difficult and expensive, and yeah, you sometimes have to come in on the weekend or the middle of the night to fix things that have gone down. And maintaining reliability and uptime are challenging. And even though we're pretty good at it, I can say it was a hassle. You know, my one-liner for having your own data center is about the only thing that's certain is that on the hottest day of the year, your air conditioner is going to crap out. And those are things that you, with your own data center, you have to deal with. You have to replace that failed hard drive. You have to get the air conditioning fixed. You have to replace that router that fried itself. So knowing that it's difficult and expensive, we were paying attention, and when we heard of Amazon Web Services, began exploring it experimentally about 2.5 years ago. And you know, the way we look at it is, geez, we can outsource our data center. Instead of buying equipment, we can rent it, both computing and storage. Sounds really attractive. This is a no-brainer if it works. And so we did check it out. And what did we find? We found that it worked really well. And after experimenting for about a year, we began a full-fledged effort to migrate pretty much as much of our infrastructure as possible up into the Amazon cloud. And as of now, we have 17 servers that function in a virtual private cloud inside of Amazon's infrastructure as a service offering. So the first part of Amazon that I'm going to describe is those 17 servers, which live in EC2, which stands for Elastic Cloud Compute. And so what did we move up there? What are the servers? What do those 17 servers do? We do all of our web development there. Our .NET and our JavaScript, our development, our beta testing, and our production environments are all there. Our hosting infrastructure is up there. We have, you know, 2 of those servers run Esri ArcGIS as a 2-server cluster. And then we also run the OpenGeo suite, GeoServer, on 2 additional servers up there. And then we do our corporate SharePoint, both for internal sites and project management sites, and appgeo.com, our company website, is also up there. And then, because it is your own network, it is just infrastructure as a service, you have to have things like a firewall and a DNS server. So there's lots of, not lots of, but a couple of those servers are just routine utility servers that help keep the network intact and secure. But we haven't been able to completely shut down our data center. I think the way we look at it is our data center has gotten a lot smaller. We still have many things that we haven't moved, may never move, and some things that we haven't yet moved. Our financial system, for example, is on our own infrastructure. Our local Active Directory and file system, we still do a lot of just routine GIS data development, data processing work, and we have our own storage area network, our own SAN and directory tree. We have 2 offices in Massachusetts and Connecticut, and we use Citrix for certain types of things, and so we host our own Citrix infrastructure locally. And we've been on Exchange for a long time, and we still host our own Exchange servers. If I were a betting man, that won't be the case for very long. And we're very actively looking at using a software as a service play. Companies like Google and others, Microsoft, have fully hosted email systems. It's private, it's secure, but you're using their server farm for managing it. And that's very attractive and very cost effective. And in fact, some states, the entire state of Utah, email is now hosted by Google through a third party. And then we have, again, the same kind of utility servers to keep our local network secure and connected, firewall, DNS, et cetera. So the bottom line for the things that we've been able to move to the cloud is that it's changed the kind of investment we make in information technology. In the old days, you bought hardware on a periodic basis, and then, your servers last 3 or 4 years, and then they need to be replaced, or the maintenance isn't covered anymore. Now you're charged monthly based on how much you consume, and this is a picture of an actual Amazon bill, and you're charged pennies per hour that your server is turned on. So if you're running a Linux server, a small Linux server, it's 3 cents per hour. And in this period, we had those kinds of servers on for 3,000 hours, and it cost us $96. If you want to run a small Windows machine, it's a little more because Amazon's got to pay Microsoft for the operating system, so it's 5 cents per hour. If you want to have a large Windows server, it's 20 cents per hour. If you want to have a large server with SQL Server on it, again, you don't have to buy SQL Server from Microsoft. You can rent it through Amazon. It's 35 cents per hour. And again, so we have our large SQL Server instance on for 744 hours in that particular month for a cost of $260. And that's how infrastructure as a service works. And it's really nice. You can turn your machines on and off. If you have your development machines, you can turn them off in the evening, and you're not charged for the hours that they're off. You can turn them back on in the morning. Or if you have a big processing job, you can turn on 5 machines and have it crunch numbers for 3 days, and then you turn them off. So it's capacity on demand. And so you can look at the numbers. This is a hypothetical scenario of 15 servers that in Amazon would cost you about $2,000 per month. The equivalent would be about $100,000 of hardware that you would buy every 3 to 4 years and manage yourself. And you can sort of quibble with the numbers and yeah, I could get servers cheaper from this supplier or that supplier, so maybe the number is $75,000, not $100,000. But the point is that the balance is pretty close, but you have this different monthly model instead of this capital model. And to me, the cost, even if Amazon was more expensive than physical hardware, I think we would still be highly attracted to it. And it's for the reasons on this slide. It's all the things that surround the computer, the air conditioning, the connection to the internet. Amazon has a much bigger pipe to the internet than we do. We have a pretty big pipe, and it's a very expensive cost for us, but it's a minuscule fraction compared to the bandwidth that Amazon has. They also are guaranteing really high levels of availability for certain elements of their system, as high as 99.999% availability. And then the bottom two are probably the most important. And maybe the first one is just as important, but it's the scalability. If you need more capacity, you can have it in minutes. There's basically a console. You say, I want a server of this kind, and it gets created, and you can boot it up. Think of the alternative. I need more computing power. I have to place an order with Dell, say. I have to wait for the order to be fulfilled and delivered. I have to install it into my rack. I have to connect it to everything else and burn it in. And, if I'm lucky, I can have it online in a week, 3 or 4 days if they deliver it overnight and it's a real priority. So that's really important, the notion of on-demand scalability. And the other is flexibility. Sometimes, I'm sure it's happened to many of us, you buy a server and it's not as big as it needs to be once it gets under load. Or sometimes the opposite. You buy a big giant server and you're only using a tiny bit of its capacity. In an infrastructure as a service model, you can say, oops, and make a smaller server, or oops, and make a bigger server. You have the ability to change your mind in a way that you don't with physical hardware and a cost of ownership model. Okay, so I think this is another good place to pause if there are any questions.
So, Michael, I don't see any questions from the audience, so let me ask one, and that actually relates back to capacity, which you just started to talk about. So traditionally, if you're buying your own servers for in-house, you imagine the most possible capacity you could need, and you basically purchase that, at least as your budget allows. So I think what I'm hearing you say in the context of a service like Amazon, it's almost the opposite. You pick either your average capacity that you need, or maybe you even undersize it a little bit, and grow from there. So I'm curious if you could expand upon that, if that's actually true.
Yeah, you have. I'm going to just go back a couple slides to the kinds of things that we do on the cloud, and you can move in multiple dimensions. For the hosting infrastructure, sometimes the best solution isn't necessarily to have the biggest possible server. You may want to have 5 servers working in parallel. So you have all kinds of different options. You can monitor your systems and you can see if they're busy. And if they're busy, you can get a second server and divide the load, or you can spin up a bigger server that just has more capacity. Similarly, if you started with a big server, and we did this recently, we had a big server that we were paying, whatever, 20 cents per hour for, and it was never moving beyond 10% of capacity. We had a lot of data for several months, and we're like, we don't need a big server, and we went to a medium-sized server, and we're able to save some money that way. So, the main thing, I phrased it kind of cheekily here, you can change your mind. You can be more systematic about it. You can monitor things and make informed choices about whether you need more or less.
Great, thank you. So we do have a question from Reese. Reese, you should be unmuted. Go ahead.
All right, thanks. I work for the National Park Service, and we're looking at and discussing and in some cases moving forward with moving things to a cloud, whether it's an actual Park Service managed cloud or some other going with a vendor. But one of the issues we run into, or questions that come up all the time, is our bandwidth is abysmal. I just tested a few minutes ago, and at 2 different sites, one of them came up at 2 megabits, the other one was 1. And when you talk about the pipeline, what would you consider to be minimal for doing web apps, for example?
It's a really good question, and I actually have a slide that talks about that and in this storage section. So let me give you a quick answer, and then I'll keep your question in mind as I get to that slide. Every time someone hits a website that you're hosting, they're using some of your bandwidth. The request is coming in, and it's using a little bit of bandwidth, and and then the server responds. Sometimes it responds with a map. Sometimes it responds saying, okay, now depress that button or highlight that polygon or whatever the website is doing. And so there is traffic, and a data point that I can give you is that of those 47 sites that I mentioned earlier that we host for cities and towns as a parcel viewer, the typical site is consuming about 1 gigabyte of bandwidth per month. So if you divide that by 30, it's 40 or 50 megabytes a day spread across time. So it depends how busy your site is and what people are doing, and it also depends what else is. We have a 10 megabyte pipe in our Boston office, and if someone is downloading through FTP some customer data, it takes a big chunk of that pipe, and everything else is constrained while that happens. And so again, one of the nice things about moving to the cloud, once your application is up there, you're using Amazon's pipe, and their pipe is enormous. I mean, I think it's literally as big as money can buy, and so that's a benefit. But what I'll talk about in a minute is there's a real constraint. You remember from my architecture slide, I was like, we do this stuff on our network, and then there was an arrow pointing to Amazon. How you get stuff from your network to Amazon is a potential choke point. And again, I'll discuss that in a minute very explicitly.
Okay, great. Thanks.
Okay.
Thanks, Reese.
Any other questions?
I don't see any, so why don't you go ahead and move on.
Okay. All right, so there's 2 different types of storage in Amazon. EBS, Elastic Block Storage, and S3, Simple Storage Service. And I'll describe the 3 of them, the 2 options on this slide. So simple storage is exactly what it sounds like. The term that's used is it's a storage bucket, and you access your files not through a directory tree, but through a URL. So your files are in the web, and each has a unique address that you can get at through the URL, and there's kind of a code that you learn to understand for accessing the files that you put there. And that's where you put static information. So all of our websites use tiles. That's where our tiles live. Some of our websites provide access to scanned documents or photos or as-built plans for a sewer system or something like that. And again, that's where we put those kinds of data. They're big data sets. They don't change, but they need to be stored and accessed quickly. And then there's Elastic Block Storage, which is essentially the hard drive for your virtual machines. And that's where we put dynamic data. So anything that goes into a database, whether it's PostGIS or SQL Server or anything, those data stores live in EBS. And it's also where we put vector data, vector GIS data. So there's two kinds of storage. And there are also 2 kinds of fees that Amazon stores. So I'll just break down S3 for you. Again, this is a real picture of a real Amazon bill, and it's pennies per gigabyte per month. So in this model, we had half a terabyte, and our raw storage cost was $68 to keep that online, very high availability. I got an email from Amazon yesterday saying we've lowered our price, not yesterday, last week, saying we've lowered our prices, and it's now going to be 9 cents. So that's what's happening to this marketplace. Your supplier's telling you it's going to cost you less. The other kinds of fees are a little harder to make sense of. You read it on their website and you're like, God, what does this mean? How's it going to add up, etc. So you're charged 1 penny for every 1,000 files that you put into simple storage. So basically, we put 4.6 million tiles into Amazon, and it cost us $46. The one-time fee, now they're up there. You're also charged a penny every 10,000 times your files get accessed. So on those websites, on those websites, those 46 websites, 7.9 million tiles were accessed this month for the whopping charge of $7.94. And that was one of our big concerns going to Amazon. It's like, geez, are these put and get fees real sleepers that are going to make it much more expensive than it seems? And the answer was no. 7 million file accesses is a lot of tiles. $8 is not a lot of money. And so that really positively answered one of our questions. Again, there's no real good way to predict this other than trying it out. And that's what I'm trying to share here is for the model of putting tiles up, covering a fairly large geography of 47 towns. So this is probably represents 3 to 5 towns worth of tiles that we're putting up each month. And then this represents, there's a few months ago, 30 sites online.
Hey, Michael, could I ask a question?
Sure.
So is it a penny per 10,000 gets regardless of the size of each one of those requests?
That's my understanding.
Okay. I was just curious.
So this is part of the answer to Reese's question. So one of those things, say you're in the state of Wisconsin and you have an orthophoto inventory of the entire state. That might be many terabytes of data. And so how do I get my orthophotos to Amazon? And it's kind of the bowling ball through the python, or in this example, a deer through a python problem. This is a very fast pipe. This is the kind of pipe a state government might have. We just heard a federal agency has hundreds of this. And this is what data transfer means. 100 megabits means 12.5 megabytes per second, 750 megabytes per minute, 45 gigabytes per hour, or just 1 terabyte per day, with an enormous assumption that you have 100% of that pipe, that no one else is using it. And typically that's not true at all. So under the best circumstances, with a super fast, very expensive pipe, you can put 1 terabyte per day up into Amazon. And so you need to think carefully about how to do it. We move all of our tiles at night, and we move them again in typically 50 square mile units, a few gigabytes at a time. And it's just one of those things you have to manage. But one of the things at Amazon, they've thought of everything. You can actually send them a physical drive, and they will charge you $80 just to handle it, and then they'll charge you $250 for every hour that it takes to unload the data from that drive and place it into your S3 buckets. So I believe this $169 represents one of the sites that we host is the state of Vermont's broadband site. And so this device stored all of Vermont's tiles. And again, it was a one-time fee. It's not negligible, but $169. And the alternative would have been a lot more than 36 hours of redlining our pipe to the internet. So again, just to reiterate, we happen to use Amazon, but there are many other choices out there. And some of the choices are big players for sort of general infrastructure as a service, Rackspace and Azure notably. But there's some specialty shops. There's a shop out of Redlands, California called Skygon that specializes in hosting ArcGIS Server and other geospatial software packages. And then we actually, for the state of Oklahoma for a while, used this outfit called VMRacks. And again, we had used VMware internally for a while, and VMRacks specializes in hosting VMware-flavored virtual machines. And so we were comfortable using a smaller outfit that specialized in that platform. And they did a great job for about 2 years. But as we became more comfortable with Amazon, we determined we could create those same machines in Amazon, and that Amazon's cost would be significantly less. And so we took, we ended our contract with VMRacks and put the Oklahoma data onto Amazon. But again, depending on what you want, there's someone out there who will do it. And again, this is just infrastructure as a service. You know, Google provides a platform for email and document sharing and calendaring and things of that nature. So our conclusions on Amazon, they were early and strong to the market. They remain innovative. Again, you know, I get an email from them at least every week about a new service that they offer. Here's a part of storage that's optimized for relational database management systems. Here's a part of storage that's optimized for running big data platforms like Hadoop or whatever the case may be. They're really fine-tuning and expanding their offerings. They remain affordable and competitive. Again, we've lived through now 2 price reductions in the year and a half we've been heavy in there, and they just sort of say, you know, a small instance now costs less, and it shows up on your next bill. And so we've been a happy customer. They have a service program. We do pay for their service. It's about $200 a month, but we get, you know, basically instantaneous email support for issues that we have, and if we were trying to do something new, they'll give us guidance. So we're not planning on switching anytime soon, but we certainly are, you know, are not advertising for them. We are just reporting our experience, and they're not perfect either. Some of you may have seen about a month ago that they had a significant outage that, you know, made the nightly news in the front page of business section. They were down for about 6 hours on the East Coast. A couple of big websites that were using them were also down. You know, no one's perfect, and we've learned some lessons from that, and we're going to put some of our stuff in another zone, so if one zone goes down, we're not entirely down. They did send us a rebate for the downtime. We got a check for $6.94 that represented the cost of those 17 servers not being online. So, you know, the standard for us is not whether they're perfect or not. It's do they do better than we could do? And we certainly weren't perfect when we were hosting our own websites either. So, you know, what I wanted to finish with is just a use case from a state agency. Again, I mentioned Utah before, and we have been doing some state-level business planning for the GIS office. And Utah took the lead on putting together a multi-state cloud hosting services RFP through the Western States Contracting Alliance. And they asked us to, knowing what we were doing, they asked us to review the RFP. We weren't planning, you know, we're not in that business. We weren't planning on bidding on it. And so we gave them some advice. And I think, you know, most of the advice we gave them is be very clear about the difference between platform as a service and infrastructure as a service. You likely want both, and they're different things, and you should be clear in your language about that. But one of the things that was ironic is while we were talking to Utah about this RFP, they were unable to buy cloud services. Rather, as Reese mentioned, there's the opportunity, and some governments, including Utah, have created private clouds. So their State Department of Technology Services had a private cloud that state agencies could use. And I give them credit. They were innovative, ahead of the game, and state agencies have some of the benefit, self-provisioning, on-demand provisioning. You can get a new server very quickly from the Utah private cloud. But Spencer was very aware of how much the private cloud was costing him. And when I showed him some of our costs for Amazon, he was like, well, Amazon's a lot cheaper than the DTS cloud. And so we ran some use cases to share with DTS about what the private sector has been able to deliver for cost. And using the sample of hosting 10 terabytes of ortho imagery a year ago, before Amazon's price reduction that I just talked about, DTS was 6 to 7 times the cost of Amazon. So if it costs you $15,000 a year to host 10 terabytes in Amazon, DTS was over $100,000. And so food for thought. How can a government take advantage of what the commercial market is delivering? And that's really where I want to wrap up. Very promising, exciting technologies that are maturing rapidly. Our experience has been these cloud companies know how to keep servers online and air-conditioned and connected to the internet. We've had very good reliability. The on-demand provisioning and scaling are really, really important, certainly as important as lower cost. And government has started and needs to further evolve to allow state and federal agencies and local government agencies to take advantage of these benefits. A state data center like DTS should not be competing with Amazon. They should be leveraging Amazon. And there will always be special needs for state data centers. There are some data that's extremely private and sensitive. There are state financial systems, et cetera, that need to be very tightly controlled. And but just as our data center got much smaller, I would foresee over the next 3 to 5 years, state and federal data centers getting much smaller, and pieces of those data centers being migrated to commercial cloud providers. So with that, I'd wrap up what I have to say, and again, be available for any questions that you may have.
So Michael, why don't we pause for a second while we wait for some questions coming in? I do have one for you. And that is, so what level or what kind of changes have you seen in your staffing as a result of moving to the cloud? Specifically, has it freed up time for some folks? Has it remained the same? I guess I refer specifically to your IT staff.
That's a great question. Our first system administrator from 2.5 years ago, when we started talking about the cloud, he got very nervous and was sort of viewing it in this way, like, are we trying to take his job away or do something? And the reality is, I'd answer your question very directly. It hasn't changed. We still have 17 servers to manage. We still have a firewall in the cloud that needs to be configured. It's just that we're managing virtual servers. And so if there's any time savings, it's like, we have less hardware, so our hardware fails less often. But we still have some of our own software. So the kind of pliers and wires work of configuring routers and installing servers in the rack and stuff like that, that has been reduced. But we're continuing. We're doing more hosting. We have more servers. We have more capacity than we ever have. And so, our current system administrator is very comfortable with the cloud, and I think it's an exciting part of his job is working with the Amazon team to build the right configurations to solve the problems that we have. So
great.
It doesn't deal with the staffing part. You need smart IT people to manage your virtual environment.
Great. Any questions from the audience? There's a question about we're going to make this webinar recording available, and yes, I am recording the session. Hopefully I can figure out how to edit that 4 or 5 minutes of no audio. Again, apologize for that. But yes, we will make this recording available for folks to listen to later. Other questions? Okay, we do have one question. Okay, Blake, go ahead.
Yeah, I had a question about if you are actually hosting a mapping application directly on the cloud, which one of the Amazon products is the best one to use for that, and also how do you go around, assigning a domain name to that on those Amazon machines?
I don't know the technical answer to the domain name thing, but essentially they are physical machines. You register your domain. We do have a DNS server in our virtual private cloud. I'm going back to our to my architecture diagram. Sorry, here it is. So these two servers are part of our virtual private cloud, and their domain is named and registered just as if they were physical boxes, and Amazon has the tools to help you do that. And if you could just repeat the first part of your question, how do you decide what?
Yeah, I mean, if you're actually directly hosting an application on which one of the Amazon products that you've talked about, what's the appropriate one for doing that?
What you would do is you would create an EC2 server. So you would, again, if you're running, I don't know what you're running, but say you were running ArcGIS server on a Windows IIS box, you would spin up basically the equivalent server in Amazon. You would install ArcGIS server on it, and you're essentially making a copy of that server in a different place. And Esri has tools. They have pre-configured machines that you can buy from Amazon that have all the prerequisites that you need for ArcGIS server. They call it an AMI, Amazon Machine Instance, and so there's sort of off-the-shelf AMIs that some software manufacturers will make available. So you would create something in EC2. That would be the Amazon product that you'd be looking at. Going back over to EC2 here. So you would, and you would decide that what's the operating system and what its size is. And then you would decide how much dynamic data you had. So how big should the hard drive for that server be? Half a terabyte, a terabyte, whatever. And that's a function of how much vector and dynamic data you have. And then if your application was using tiles and images, you would also use S3, and you would push the data over there. S3 is more affordable than EBS, so there's an advantage when you can use S3 to use it. Does that answer the question?
Yes, thank you.
Thanks, Blake. Great question. Well, Michael, I think we've reached an hour here, so we should probably wrap up. I'd love to get so thank you, Michael, very much for taking time out of your day to join us today, especially being on training out in California. For everybody else, I'd love to get some feedback on today's session other than our little audio snafu. Would you like to see future webinars on other topics? Drop me an email anytime. I'd love to get your feedback. So thanks, everybody. Have a great day, and thanks again.